Hello everyone. This is Mohammed Yamam. I'm the Windows Phone Technical Evangelist for Microsoft Middle East and Africa. That's my Twitter handler, m_yamam, and that's my blog that you can find on the screen. Today we're going to talk about the application lifecycle on Windows Phone 8. It's going to be pretty much of a different session actually. I just changed the whole demos. I just made a very super simple demo with almost 0 lines of code, so that I just wanted to show the application lifecycle in the Windows Phone 8 with the simplest things ever possible that I can do. So I hope you like the demo, and I think it should be easy. So let me know by the end of the session if you find it easy or not, or you might have you might wanted it in a different way. So let's get started. So today's agenda is, as I talked before, it's going to be about a Windows Phone 8 application lifecycle. We'll talk about the launching and closing, deactivating and activating dormant and tombstone apps, how to use the simulation dashboard in your Visual Studio and to simulate lock screen, the lock screen and the unlocking mode. We're also going to talk about the idle detection on Windows Phone. So let's get started. So first we'll take a high-level look at the application lifecycle so that you understand the events and what they have and when they happen and the effect on how your application would operate. So Windows Phone applications lifecycle. So as the diagram, as you can see here, it shows how the application, the states of the application. The application can be in the state of not running, which means that the application is not running, or the application might be running, and from application to move from not running to running, it should be launching, and from running to closing the application, there's closing, which happens with a back button. So these are all different stages of an application lifecycle. So in summary, the user launches a new instance of an app from the start screen, or the apps menu, or from a deep link through a secondary tile or something, a speech input, like for example, open my app, and we're going to have that in the speech session. Can be also through search extensibility on the phone, or the wallet, or using files or protocols, like opening up through an attachment, a PDF file, so that he opens the PDF reader application you have on your phone. So all of these examples would make an application go from the not running to the running mode, and hence so the application keeps launching till it runs. So there are some things that happens or an event that is being triggered when the application moved from the not running to the running state. So what about moving from running to not running? So if a running application loses focus, so by the user starting another application or getting an interruption such as a phone call, or something like that, so the application would move from the or you press the search button or the window button on your Windows Phone, the application moves from the running to the dormant state, which means the application is being deactivated, and you can get back to the application by pressing the back button. So you're coming back from the dormant to the running state. So that means you're activating the application back and moving it from dormant state to the running state. So dormant apps, what is dormant? So dormant apps are cached. So these are applications that are cached for fast reactivation. So if the cache becomes exhausted, then a dormant application may be tombstoned. Which means that if you have anything in your application, like a user input or something, and it was not saved, if the application is dormant, that means that the data on that page is cached in the memory. Then when you go back to your application, you should find everything there in the application without even needing to load it again, because it's already it was not lost. However, if your application runs out of memory, I mean the cache memory if your phone is running out of cache memory, then the application would be tombstoned, which means that the state of the application would be deleted, and we'll go through all of this in our demo. So do I have a question? Okay. So each of the key lifecycle events has an event, and you write that event handler in the app.xaml.cs or .vb file placed in your project. So So this event, the Windows Phone application environment notifies an application about these lifecycle events, and in the project templates you'll find these in the app.xaml file. And initially this event handler methods are empty, and that's what I'm going to use in my demo. So what we just saw, when a Windows Phone 8 application is started, the application launching event method is called. So this is when you need to load the content from files. So if you remember the last sessions about loading and saving data, we used to do that in the app.xaml.cs, and we did not go through much of details. So you can load a lot of things during the application launching or the application being closed. Honestly, you know what? Let's guys go to the demo. I love the demo would show it would make it an easier way. So here's Visual Studio. I'll open it right away. Honestly, I feel like this session should not be slides. It should be just through Visual Studio first and demo, and then you do that. So I'm just creating a new application. So here's the Windows Phone app. I have someone not on mute. Can you all please go on mute? Okay, we've got Cindy. Okay, thanks, Cindy. So Windows Phone application. So I'm just creating an application targeting the Windows Phone 8.0, and the application is starting. So here's a normal template for a Windows Phone application. In the app.xaml file, this is what happens in globally to the application. You'll find these 4 events. Let me scroll down. Here are they. The application launching, the application activated, the application deactivated, and the application closing. And you'll find even the comments telling you, so this code will not execute when the application is reactivated. This code will only execute when the application is launching, which means from the start. And the activation, which means that this code will only launch when the application is being activated, which means that if the application goes to a dormant or to a tombstone state. So while deactivation, this code will execute when something interrupts the application, such as if you get a phone call, whatever or you press the start button. So this means your application will go to a deactivation mode, which means that any code you put here will be running. So for example, like you want to save the data of the application, the user input, whatever you want to do, you can save it here so that you don't lose any of your data. While the closing, which it's closing, so whatever code you'll put in the application closing, that's the code that will be executed when you're exiting the application. So actually the simplest demo I thought about it is just adding a breakpoint on each and every one, and then just debugging and showing you guys how would that run. So let me run it in an emulator. Here's the emulator. So what's happening now? The application is being built. It's an empty app, but what's happening is we've got the application launching, activated, deactivated, and closing. So now the application, once it's being deployed on my emulator, and the emulator is okay. Oops, there's a problem with my emulator. Let me check. Maybe I have another instance running. This is weird. Give it a build. This is not what I expected. Give it one more shot. No, I didn't add any code. I just loaded a template. Something was starting a virtual machine. Not enough memory. Wow. Okay, let me check, guys. Maybe I'm running out of memory. So okay, let me use another emulator. I already had an emulator running. Let me just reuse that emulator. Okay, here it is. So as you can see, the application is being deployed, and the breakpoint here is being activated. So that means that this now I'm stopping at this point, which is the application being launched. So whatever code I add here, it will be running before the application launches, which can be like loading data. You can do whatever you want from whenever you want to start your application. So let me continue. So here's my emulator. Here's the application. There's nothing about it. So what if I press the start button or the search button? What will happen is the application will move from the running state to the dormant state. which means that from running to dormant state, which means that the application will be deactivated. So if I press the start button or the search button, then the application deactivated method should be, or the application deactivated event should be triggered. So let's see, and here it is. Now it's triggered. This is exactly what's happening. So whatever you can put here, for example, you can save data while having the deactivation. You can, so because if you're not planning to come back to the application, so whatever code you're adding here, can be exactly the same what you're doing with an application closing. So that's what's happening with the deactivation. So let me continue. If you check in the if you check in the background, so let me see. Check here. So we've got this fast application switching, which when you press two back buttons or a long back button press, then you'll have like whatever applications you're having. So if I press again on this application, or that means I'm relaunching the app. So the application is being activated. So I can load the data in the activated event. So whatever like the data so for example, if you're having a timer being in the application, then you could have in the deactivation mode like a timestamp when you stopped your application, and then when you're being back, then you can add this timer and then update the values of that timer in your application when you are in your activation mode. And then going back, so let me just continue the debugger. And then what about I'm closing? So back button means I'm closing the app. So I may want to execute some code in the application closing method. So do you have any questions or anything might not be very obvious in that demo? Because actually this is kind of sums up everything, but I need to talk to you about a lot of things in the theory of the launching and the activation and the deactivation, and then before I move into the idle state. I feel like this is really the most simple demo that I could think of for explaining the application lifecycle for a Windows Phone. Okay, things are clear. Do you have any questions? Do you want? I'll do a recap at the end of the session, but if you have any questions, please stop me. Okay, thank you, Smelia, for that. So let me get back to the slides. So in the demo we've just launched. So when a Windows Phone 8 application is started, the application launching event handler method is called. So this is when you need to load content from files in the storage to set up the app for running, for example. So when a Windows Phone 8 application, sorry for that. When a Windows Phone 8 application is closing, and then you run the app. And then what about when you're closing the app? Then the application closing event handler is being called. So, and this is kind of your last chance to save the data in your application, for example, in your storage. And that's what we've shared in last session about files and storage. But I did not talk about what's really happening in the background. But this is exactly what will happen. Application deactivation and reactivation. So if traditional Windows desktop apps work the same way. You start them, they run, then you close them. Starting and closing are the key life cycle events for a desktop app. But smartphones, and Windows 8 and Windows Store apps too, work in a very different way. They're designed to protect our most precious resource, which is the battery. Right? So the result is that as soon as the app is no longer actively engaging with the user, that is, as soon as it loses focus, it gets suspended. They can be reactivated later, and they can be reactivated later when the user goes back to it. And while they're suspended, they're not using any precious phone resources. So Windows Phone and Windows 8 Store apps have to deal with being deactivated and later deactivated, and that's what we have shown in the method or the events being triggered on the deactivation or activation or launching or closing whenever the application is taking place. I think we've shown the demo. With the demo we've just shown, like we've shown what's happening when launching, closing, activation, and deactivation. So what about dormant apps? So what we just shown in the demo, that the user can make an application go dormant by just by switching to another activity, or if the lock screen comes up. So to making a dormant app, which means that I'm sorry, I'm getting lots of okay. So that means that going from running to dormant, that means if your application is being deactivated, it goes from running to a dormant state. a dormant state application means that the application is maintaining, or the OS operating system is maintaining the state of the application and whatever data you're having in this application. And as long as the memory allows the application to keep, the application is staying in the dormant state. What if the cache memory of the OS is running, or the OS is running out of memory? Then the application will move to the dormant to the tombstone state, which means that the all the data being used in the or the saved data state in the, by the dormant will be deleted. So you have to make sure that if you're moving if you're being deactivated, to save the data just in case if you're returning from a tombstone or a dormant state to being activated. So if you're returning from a dormant state, that means that you do not need to reload the data. If you're returning from a tombstone state, that means that you need to reload that data back. So there's no guarantee that your application will ever be resumed if it is made dormant. But however, you can actually know whether your application is made dormant or not, or is being tombstoned or dormant or not. Let me show you a quick demo about how to about the application being dormant or being tombstoned. So here, let me remove these and stop debugging. Okay, I think I'm having a question. Okay, no. Perfect. So let me add in the toolbox here. From the toolbox, let me get, for example, a text box, and just drag and drop it here. Okay, just a simple text box, and then run my application. So here's what we get: a text box, right? So I can delete and remove what's in the text box. So for example, like app lifecycle, right? So now there's nothing saved in that text box, right? I'm not loading or saving anything in the application. So if I go back from the application, that means I'm closing the application and return back to that app. Okay, sorry for that. No. So phone app 25. So that's the app I'm running. I'm getting it back as a text box, right? Because I did not save anything. That's what is being loaded when the application is launching, right? In the constructor of your app, just loading the controls. However, if I change what's inside, and for example, add app lifecycle again, lifecycle, no, whatever, app life, and then I just press the start button. Again, I did not save anything, but when I press back, I find the app life again. Why? Because the application was moved to the dormant state, and the OS still has memory, so it kept it at the dormant state. What if I want to tombstone that application and check how is the difference between tombstoning and dormant? So if I'm returning from a dormant state, I don't need to reload what the user has been writing, right? So let me do something that you all like. If you go into your application and your properties, in your project, and click properties, you'll go to your debugging. There's this option that you can use in your Visual Studio, which is tombstone upon deactivation while debugging. So when I tick that one, that means I'm gonna run again. So whenever I deactivate, I will remove the application from the cached memory. So here's again app life, and pressing the start button, and now the application is deactivated, and it's moved from the deactivation. It did not move to a dormant state. Actually, it was just tombstoned upon the deactivation. When I press back, I don't find what I already wrote. So that means I'm coming back from a tombstone. So that's what you can do for testing purposes, and make sure that test how things are being done from while tombstoning or coming back from dormant state in your emulator. But what about a real-time scenario? That's what we're going to show in the next slides. Actually, I think I should have just stuck to demos in this session. So first of all, any questions? Anything unclear? Do you know the difference now between a tombstone or a dormant state? Questions? Oh, Johnny's finding it clear. Guys, if you need me to repeat anything, please let me know. Huh. I love that. I mean, so is the demos? I mean, do you think the demos are enough to show the differences and everything? Because actually, that's the first time for me to use these kind of demos. Yeah, thank you. So let me get back to this session. So again, like dealing with dormant, when your application is made dormant, it must do as much data persistence as if it's being closed. Why? Because deactivation I mean the application deactivated or the application closing will mean the same thing if the user never comes back to your app, right? So that means if you never come back to your application, that means that that you're going to lose the data. So that means that you need to do much of data persistence, like saving data and what have you. Your application can run for up to 5 seconds to perform this kind of tidying up. So after that, it will be forcibly removed from memory. So when you are deactivating or closing the app, you will have up to 5 seconds to do the tidying up. For example, like saving data to your database or to your storage or whatever you want to do before your application closes or being deactivated. So as a kind of a best practice, never keep saving the data till the end of your application. You have to, I mean, like a better practice would be to save the data once, I mean, like as more frequently, so that whenever you're leaving the application, then whatever is being left with the data, then you're saving less data. That means you're consuming less time and to add to your database. While you're consuming less time whenever you're leaving the application. Okay, so this is kind of a, that was a kind of an example. Reactivating from dormant. I think the demo we've shown is more than enough to show that. I didn't want to use slides for that one. Resuming from an application or fast app switching. In the again, for resuming an application can be during pressing on the back key or what we've shown earlier, pressing on a long press on the back button, which would show you what you've seen here and what you've seen in the demo with thumbnails or screenshots of the latest state of your application. You can do that, and this is actually for you to know. The app history stack can hold up to 8 apps at a time, so that's for you to know. So then you can swipe your finger and then open an application back without you going through the back button and just clicking which application you want to activate. You'd like to activate. From dormant to tombstone, I think we've discussed that, how an application will be held dormant in memory alongside other apps. If the OS becomes short of memory, it will discard this cache state of the oldest dormant app, and this process is called tombstoning. You're kind of tombstoning the app, and anything any state of the application will be lost unless it's being saved. So when a dormant state is app is resumed, the application resumes running just where it left off, as we've shown in the text box and what we wrote in the text box, even without saving. What about a tombstone app? When a tombstone app is resumed, that means that the text box or that we had reloaded what it had before, so it restarts at the correct page, but all the application state has been lost, so you must reload it. So that means that in the deactivation you might need to save what the user have written in that text box and then reload that one when the application loads. So can an application determine which state it's being activated from? I mean, like tombstone or dormant? Yes, and we'll show that in a few minutes. Like activation from dormant and tombstone. I think the demo is more than enough actually to go through that. So resumed from dormant or tombstone in the application, again, like when you're coming back from a dormant state or a tombstone state, that's when your application is being activated, which means that the event of application activated is being will be triggered, and then whatever code is being there will be executed. So this is actually this if-else condition is what you need to know whether the application is coming from a dormant or from a tombstone state. So if the activated event argument is application instance preserved, which means the application is coming from a dormant state, the instance of the application is being preserved, then dormant objects in memory is still intact, so you don't need to do anything, or you might need to do something. It depends on what you want to do. Else tombstone, then you need to reload what was inside. So for example, like load what's inside the database or load what the user was writing in the text box. So let me yeah, that's debugging. So let me actually show you how we. Okay, I have a question here. Okay. Oh wow, lots of questions. Would you please repeat as me and Zareen lost connectivity for 10 minutes due to some technical issues? Osama, I will do a recap, so no problems. So but if I need to call service, what the maximum time delay that the Windows Phone can accept? No, calling a service is different from if I get your question right, calling a service is different from from leaving an application. I mean, like exiting an app or deactivating an app. So if you want to do that by while leaving the application, then you might want to if it's again it's the time that you need to do what it's not just about saving data in the storage. You can use that time to do anything, to call a service, to do whatever you want. So it's the same time you need. So actually, what I might do if I were you, for example, like yeah, I can do two things. First of all, I can save what I want to do through a web service locally first, and then I can do that kind of a call. And if that call would take much time, then maybe you can do that with a timestamp. It depends on your application. Then reload that when your application is back, and then send it while the application is getting started, and kind of backing it up. So it depends on how you're doing it before you're leaving the app. If my app goes to dormant state while I'm downloading, what will happen about the connection? It goes to while I'm downloading. It depends. I mean, like if you are if you need to use some asynchronous code, or you can make the application be running in the background. We can do that in the background agent or the background transfer. There's a different work that we can use for a background transfer. Let's not go to that thing. I think we might go through it in the next session or the following session or so. So I just don't want to get through that right now. So yeah, what I wanted to share with you guys, yes, is the activation and yeah, the application activation. Okay, that's Tombstone. Okay, let's keep it, deactivate that, and go to the app.xaml.cs. The application activated. So to check, okay. So here's my if condition. So if is application preserved. So, which means that am I getting from a dormant state? So that means that whatever is being here is the dormant. I'm coming from a dormant state. Else, execute what is here. Like I'm tombstoned. Tombstone. So let me just put a breakpoint here for the activation to let me run it again in the emulator. Here is the application, and on buttons are deactivation, and then a back, and is the and then if this should be true, so just like F10 and then yes. So I'm executing what is inside, which is the application is being dormant. Okay, but if I get the application from a deactivate from a tombstone state, which means that I need to go to here and just make it a tombstone while deactivation. Okay, then deactivation, activation again, and then F10. So this means that I'm coming from a tombstone state. Then I can load whatever data here, or whatever, like reload the page or whatever I want to do in that state. So that's how you can do it. This how can you know when you're coming back from a tombstone or a dormant state? So any questions about that? Questions? Wow. Oh. No questions. Should I? Yeah. Okay. That's okay. No questions yet. That's really cool because we are almost done here. So that's cool. Okay. So what about running under lock screen in Windows Phone? The user configures the screen timeout in the lock screen setting on your phone. Like timeout can be 30 seconds, 1 minute, 3 minutes, or 5 minutes. These are the time needed for the lock screen to be for your application to be locked. So after a period of inactivity of the selected timeout, the screen turns off, and the lock screen is shown the next time the user turns on the phone. So by default, the active app is deactivated when the lock screen comes up, and the applications can request that they continue to run under the lock screen or not. So a good reason for doing this, if the application is in the middle of a long file transfer, okay, or some other long-running activity, it can continue to run under this lock screen and complete whatever it is doing. So this is what you can this is how you can use to detect the phone idle in your Windows Phone. You can deactivate, you can disable it or enable or keep it enabled by default. So this is just beware while using this, because overuse of this will eat your battery up. So it will make the user run out of the battery. So the user might not like your application if it consumes too much of their battery. If your application, for example, is a background transfer, or you're for example, like a user would use that for a navigation, map navigation or something, then you most probably don't want him to have his application being deactivated unless he exits the app. So how do we disable the idle detection? It's very easy. Just one line of code: phone application service, the current application idle detection mode. You just turn that to disabled. Once you use that one, then you're done. I mean, like you can just lock or unlock your actually keep your application running in the lock mode or the unlock mode. Okay, so let's give a quick one about that one. How do we do the lock screen and the unlock screen? So here it is again. I'm running the same app. Okay, let me just whatever here, like app life again. I'm not sure what's app life, but it's what I wrote in the beginning. So let's stick to it. In the quick launch, you can just go to the dashboard. Yeah. You can either I like to use this quick launch. It's a very powerful tool in my Visual Studio, and just use the simulation dashboard. And inside the simulation dashboard, you can find like you can enable network simulation, network speed, signal strength if your application is using network, and then you can use the reminder and trigger reminders. And then we've got the lock and the unlock. So if here's my application. If I just press locked. Oh, that's weird. The application should turn actually into a locked mode. Actually, it's being loaded. I just hope my my Visual Studio does not break. Yes, that's why. Just create a virtual machine. Let me try it one more time. Let me run it again. Okay, locking. This is pretty much not what I expected. I might need to restart my emulators. So let me restart my emulator. So what I should expect here. Okay. I'm just restarting my emulator again, reloading it. Let's reload it. So what I should expect when I lock, that the deactivation the deactivate would run. Oh. Not enough memory. No. Okay, let's one last time, and then I'll need to remove some stuff from my memory. Not my memory, my laptop's memory. Just hope that one does not break. Do we have any questions? Do we move on? Yes, questions meanwhile. Thank you, Osama. Please. Do you have any questions till the emulator loads? I have a favor. Okay, Johnny, what's your favor? When an okay, we have a question. When an application is running, then what is the current behavior? Nothing. The application is running. That's a state of your app. So, oh, okay, sure, Johnny. Okay, so when the application is running, there's no behavior being, just the application is being running. We're just talking here the application lifecycle, which is transferring from a state to another. We've got 4 states, which is dormant, tombstone, running, and not running. And moving from not running to running, that means that your application is triggering the app launching the app launching event here, or the event here, and then you can load some stuff where the application is launching. If the application is already running, then nothing in this would be running. If the application is closing, which means that inside your application you're moving from the running state to the closing to the application to the not running state, then that means that on the way from running to the not running, once you press the back button to exit the app, any code you put in the application closing will be executed. What about if you press a start button or if you get a phone call? That means that the application will be deactivated, which will mean it will move to the dormant state right away, and if it runs out of memory, it will move to the tombstone. So, and when what state our app goes? It goes from when you press the start button or the Windows button, then that means that the application will move from the running state to the dormant state right away, which means that the application deactivated event will be triggered. And then if you're using too much of the cache, and the application state will be cached in the memory, and if the cache and if that and the operating system does not have enough memory to keep your application in that state, it will move it to the tombstone state right away without informing you. So whenever you want to reload or to activate the application or run the application back, that means that the application will be activated. So if it's coming from the dormant state, there is nothing that you need to reload because everything is kept in the state. If you're coming from a tombstone state, then you need to reload what's inside. And the way you can detect that is through this line of code. If there is application instance preserved, then things should work. Yeah, that's resuming. So running dormant tombstone, not necessarily closed. Not necessarily closed, if that's the question. Unless you mean, so yeah, these are the states: running, dormant, tombstone, and already closed. Yeah, these are the states for the app, if that's the question, Christian. You're welcome, Mustafa. So the emulator is back. Let's hope this lock screen would work. Yes, nothing. So here's the lock screen. So you can unlock yep. And once I press the locking here in the dashboard, I get the application was deactivated. I just continue. Whatever code in the deactivation will be running, and then if I unlock it, the application will be activated again. And if it was in the dormant state, then whatever here should run. But since in the debugger, okay, just continue. Since the debugger we did not add that. Wait a second. We just said tombstone while on the activation. Oh, sorry. Okay, thanks. So that's what happened when you can use the simulation dashboard for locking and unlocking your application. What about if we want to use disable the idle detection? You can go, for example, in the main page. For example, like here, like I can just go in the main page. I just add the phone application service .current application idle detection mode, and I'll just assign that to idle detection mode to disabled. That means that if the application, once the application runs, I don't want the application to lose to move to deactivation if the lock screen is there. So let me run it one more time. The breakpoints are there. Let me double check. The breakpoints are still there. Yes, perfect. And in here in the dashboard, when I press the lock, nothing happens. Nothing in the breakpoints run, right? And here's on my emulator, it's locked. What if I want to unlock? Nothing again happens because I disabled that and make the application keep running under whether it's being logged or not. So this is very important for you. Depending on your application, you can do that. Depending on the application logic, you can disable that idle detection and for the application. So any questions so far? Questions? Okay, cool. I love that. So let's get back a quick recap to finalize this. Honestly, I told you guys it's going to be a very quick session. Again, so just oh, okay, sorry, that's my mouse. So this is a quick summary. This is the Windows Phone application lifecycle. These are the states. You know, I think it should have added like a not running one up there, or an application is not running. So whenever your application is running, so we've the ones in green, these are the events that are being triggered when the application moves from the not running to the running state. So the code will be executed. The application launching event will be executed. There is the onNavigated to method also. Whatever you add in the onNavigated to method will be executed as well. So that's for an application that's application specific, or kind of a global per app, and this is kind of per page. Okay. What if you're running and then you're closing the application? So that means that the onNavigated from method will be executed, which means if not a backward navigation or something, so you might need to save some stuff here, or the application closing event will, and the application closing event will be triggered as well. What if you press the Windows button or the search button, or you get a phone call, then the application will be deactivated. So that's the event will be running, and whatever it's and the page onNavigated from method will be called as well. So and then the application moves to the dormant state, and then the application stays in the dormant state unless the operating system loses doesn't have that amount of memory to keep it in the preserved state. So the operating system will move the application from the dormant state to the tombstone state. So you can reactivate the application back either from a dormant or a tombstone state, and depending on how you manage your logic and the deactivation method or the onNavigated from, then you might lose the code, the data or not through the you can reload the data if lost through a tombstone through the activated event, or you can reload the data for that specific page on the onNavigated to method. I think this is kind of exactly what we've done, and this is the Windows Phone application lifecycle. This is how it looks like. Do you have any questions? Because honestly, like, I know like this is it for today, and I've been kind of going beyond the hours every time, so this session is kind of shorter. But I hope it covered it all. And for Usama, because you came late, I can give you a quick I can show you the quick demo again that I gave in the beginning of the session if you joined a bit late. So any questions before I stop the recording and show Usama the demo again? Questions? What's the difference between reactivated from dormant and tombstone state? We will show that right away in the demo, Bassem. Okay, so let me stop the recording, and thank you for making it to this call, and stop recording.